friends, I welcome you once again in our channel. The name of my channel is as you familiar that its name is Unique Classes by Mother Sir. Today I am coming in front of you because of a new topic which I have to brought. The topic name is electric field. My friends, you know that you are aware about the electric charges. Actually, whenever the charge is placed in somewhere in the field, actually it produces a different type of environment, and that environment cannot be neither or in any way we can realize by our hands or anything else. If you want to realize that the environment created by a charge, it would be you have to bring or you have to bring put a charge in front of that field or in that field. Okay, then you will can realize that the either it would repel the charge or would be attracted by the charge. So actually, what is the electric field? We can discuss about the electric field. What do you mean by the electric field? Electric field is nothing but actually it is the an environment or the field produces by a charge when any other charge will be experienced will be placed on such a field, it will either experience a repulsion or attraction. So we do not have any doubt about the charge. You know that the charge which produces the field, that is called the source charge, and the charge which experiences the electric field, that will be known as a test charge. Okay, so source charge generally should be considered as a more than our test charge. Now we are going to discuss about the electric field intensity. We know that firstly I just want to say one more thing, that the electric field by itself is invented by the Farad, and now we are going to discuss about the electric field intensity. Okay, now the electric field intensity, what, as I am given one example, that whenever we are purchasing something, we are not until we will not find out its rate, then it is not worthwhile. It is not a so many it will not give so many cents. So definitely whenever as I discussed in the classes, that in the lecture, that the force actually experienced by a charged particle. Okay, so what is the actually force, and how much the force is experienced by a charged particle, that is the electric field intensity. So suppose the 10 Newton force is experienced by 5 Coulomb charge, then the 10 Newton, then 5, 10 upon 5. So that will be our electric field intensity due to a charge. Okay, so the thing is that electric field intensity is measured in this way and written is f. This is the actually a vector quantity because it has a certain direction, and the direction is, what would be the direction? The direction of the force and the electric field would be the same. The direction of the force and the electric field would be the same. I have written here the electric field intensity, the direction and the force, both are in the same direction, same. The force, the electric field intensity is measured in this way, f by q naught. So that's why what would be the its unit? The unit would be the Newton and Coulomb. For what reason? The force is here. You can see here the unit of the force is Newton, and similarly the unit of the charge is Coulomb. So Newton Coulomb minus 1 would be the unit of the electric field intensity. Okay. Now electric field, as I have written here, the electric field intensity and the force both are the same direction, and both are the vector quantity. Now friends, I would like to attention you that actually what would be the direction in the case of the positive, and what would be the direction in the case of the negative. Okay, you can see here the positive whenever a electric field intensity is measured, generally it would be outward. It will be outwardly from the, you have to move from a positive charge to outside. Okay, so that will be the electric field intensity. Okay, the direction. And in the case of the negative charge, you can see here that it would be inwardly toward the negative charges. So this is the exactly the notation which I have written here. Now the major thing which I come in this class to discuss about the electric field intensity, what would be the expression? You can see here the expression is independent of the test source charge. You can see f by q naught. It is not the q. So q source charge, actually that what it said in this expression, the expression speaks about the electric field intensity is independent of the source charge. the major thing has been spoken by this statement, by this equation. So now we are considering about the electric field due to two charges. You know that suppose it is the positive charge, so definitely the electric field will be produced by it. Similarly, we will have a test charge on the other side. Okay. Now, since it is the test charge, what we are comparing, that source charge would always would be greater in magnitude compared to the our test charge. Now, the greater charge means the our source charge is producing the electric field. Similarly, the test charge will also positive, and it can also produce some small electric field around it. So what will happen in this case, my dear friend, you can see here, I am taking a point in the mid of these two charges. You can definitely can say that the electric field intensity would be affected due to the charge q naught. Due to the charge q naught, this is the test charge. So definitely the it has been attracted or affected. So what we are, suppose I want to measure the electric field intensity at this point. Definitely what I have intention, that I have to count the q. I wish the magnitude of a q naught should be as small as possible, so that it will give the maximum electric field intensity at this point. So what is our intention? The test charge should be taken as much as small as we can. Okay. So now the electric field intensity equation has been modified in this case. What I have written in this here, we can see here that electric field intensity, this one electric field intensity in the vector form. Now I have put here the limit. Limit means what? We are expecting that as the q naught tends to 0, means you can see here, whatever the q naught, as much as q naught would be small, we will have the maximum value of the electric field intensity. That's why, my dear friend, and here you should attention that we have written here the limit q naught tends to 0, fr by q naught. Similarly, if you see here that the q naught, as much as q naught would be minorly positive, then what you will have, you can see here that it will be affected, and if it will be negative, the electric field intensity will be increased. So my dear friend, we have to understand the concept actually, what is the electric field intensity in the case of the positive and the negative charges. Now suppose I have taken here a source charge. This is the source charge, okay, at O, and I have to measure the electric field intensity E at this point. Okay, what is the name of this point? Is the P. Okay, so P, and I have taken here the q naught charge. Okay, now the q naught charge, and what I have assumed that it is the distance between these two charges is r naught. Okay, my dear friends, as we know that from the Coulomb's law, what is the Coulomb's law? The force of attraction between the two charges or the repulsion would be the product of their charges and magnitude of the product of their charges, and the inversely proportional to the square of their distances. So I have written 1 by 4 pi epsilon naught q. Q is the source charge, q naught is the test charge, and upon r naught square. What is r is the distance between these two charges. And what about the r naught? R naught caret. R naught caret is the vector notification. If you write in the vector form, you have to put here r naught. Otherwise, there isn't any problem. Okay. Now, you know that my friend, suppose I am going to find out the electric field intensity at the point P. So we know that the electric field intensity is nothing but it is the F by Q naught. So F by Q naught I have written again. So F, what is the F? This equation suggests our F. So F I have written completely. After then the Q naught was from the beginning we got the Q naught. So Q naught will be cancelled, and you get electric field intensity due to a charge Q. Electric field intensity due to a charge Q is equal to Q by 4 pi epsilon naught 1 by r square, and the r naught caret. So my dear friends, if you are thinking that I bought a new concept for you, and if you liking my video, definitely you put some like or the even some comment on our video, so that I will get maximum energy to bring such a nice video for you. Thank you, and subscribe my channel.